everyone. I'm Rich Harrison. I'm the regional sales manager for Array Networks. I also have Ed Kuiper is the regional systems engineer. He's at the table in the back. We're going to try and make this quick. Our topic today is a layered approach to web and application security. So just a little bit about Array. Array was founded in 2000. We're headquartered in Milpitas, California. Support manufacturing are based out there. We have about 400 employees worldwide. We have offices all over the world, including Europe, India, and throughout Asia-Pac. Our focus is ADC, or server load balancing, and remote access. We also do WAN optimization. Our clients typically are companies that are compliance-driven, so we're very successful in financial and healthcare, mainly because of the SSL and the encryption aspect. What we're going to talk about today is why to take a multi-layered approach. We're going to give you some examples of an architecture. We're going to talk about application delivery, also SSL VPN, and just a little bit about Array. And then if there's some time, we can open it up for questions and answers, but we'll be here most of the day at the table in the back. I think we're all familiar with the perimetered approach. I think anybody that has been in a bank or has entered a secure facility understands, the layers of physical security. We know if you do it in layers, it's a proven model. We know that with a layer, even if you get through one level, at least you have to go through a couple others to get through there. It also gives you an early warning, and you just got to ensure that it's scalable. We talk about why a multi-layered approach. We talk about encryption. The challenge with encryption is at the firewall level, essentially if your remote access users going through the firewall, that traffic is encrypted. Because it's encrypted, it's very difficult to analyze that traffic unless you have the keys, the encryption keys, to analyze it. And there are ways to do it, but we'll show you how you can accomplish that through a layered approach. I don't know if you're familiar with the Heartbleed exploit. There's another one called Poodle in the last year or so, but this has really kind of opened the eyes once again, of the security community. It was pretty devastating. A lot of the manufacturers were affected. We're a proprietary OS. Unfortunately, we were not affected, but never say never. So we talk about, why. Well, security is changing the way we look at network access. I think security is changing the way we look at a lot of things these days. We have employees using personal devices. People want to use things like iPhones, tablets to access the network. Layer 3 is not practical, and it's mainly because of things like iPhones and iPads, which we know very little about. And also people want to use personal devices like home machines and Macs to access the network. Most users don't need full network access. Most users are probably just checking mail. So why kind of give them the keys to the kingdom when you can just give them access to a specific service on your network? The newer access gateway platforms out there provide multiple access methods. So, and we'll talk a little bit about that. I was trying to make this less salesy. And the whole key is to limit direct network access and direct access to applications. We can talk a little bit about the perimeter. We have firewalls typically at the perimeter. SSL termination or traffic inspection. What we mean by that, these are your access gateways. People connect, authenticate, and connect to the network. And then the more advanced security appliances. This is your typical architecture here. If you see on the front end, we have the firewall. two appliances in the middle. You have a load balancer up at the top, and then on the bottom we have an SSL VPN appliance. So typically you would have the load balancing for things like HTTPS connections, so your encrypted web services. And then on the bottom, the access gateway is more in line when you have users that need to authenticate first and then connect to the services internally. And then on the back end, you might have things like web application firewalls or intrusion prevention. So we talk about layer 3 stateful packet filtering. This is something we've been doing for a very long time. I mean, I think a lot of us refer to them as ACLs, or access control lists. Layer 4, we kind of go up the stack. And then as we go up to layer 7 in the TCP stack, we rely on WAF and DDoS. In a lot of cases, when you're lower in the stack, I talked about things being encrypted and not visible. That's why you need to you have the multi-layer, you terminate the SSL, you unencrypt it, and then you send it to your inspection devices before you allow that traffic on the network. So there's a number of ways to do this. We have security through SSL encryption, WAF, and web proxy. The other thing is acceleration. Encryption is intensive on the processor. So what you want to do is you bring in your users, we terminate the connection, they either authenticate or we pass them through, but the important thing is we're a full proxy. So the user connects to us, we terminate the session, and our devices open a new session to the inside. That actually accelerates the traffic because in many cases we're doing the encryption in hardware rather than like in a virtual environment where you might have be trying to do this on an Intel chip. In server environments, when we do this acceleration, typically we'll see like a 50% performance gain almost immediately when you install it. And then high availability. When you talk about load balancing, it's about providing an even distribution across your services on the inside, but more importantly, we do health checks. So if a service is down, we don't forward traffic to that service. We just redistribute the load across the healthy services. The SSL VPN is a little bit different. There's 3 types of users. There's a user like myself that's on the road all the time. I have a corporate laptop. I don't have any devices at corporate. I'm only out there twice a year, but I do need network access. My machine is set up by corporate. It has the appropriate firewalls and antivirus, so on and so forth. Now we have home users today, like on a snow day, especially up in this area, where users might want to go home from their local PC, from their home PC, connect to the network. We don't know anything about these devices, so the way we handle that is that user connects to us, we terminate that connection, and now we can either give them access to a web service or to a desktop, which can be physical or virtual, or even an application running on a terminal server. The key is, in that scenario, we only pass keyboards and screens. So all the data remains on the network, you limit data leakage, and what you also do is you limit the exposure to your network. The things we can do for a device like my device, let's say I'm on the road for a long time and I don't update my antivirus. We can do an endpoint check. So the user connects, we scan the machine, we check their antivirus firewall, we can even check things like registry keys to ensure that we own that device. We can do some advanced authentication. We support 2-factor with either RSA or Duo security. We actually have our own one-time password feature that's built into the appliance. So if you're a smaller shop, lower budget, you can now enjoy that extra protection. And then deep packet inspection, we have a built-in mechanism to look at things like malformed packets or unusual types of traffic come in and actually drop those packets. So this just kind of lays out each side here. So we have our APV series, which is our application delivery controllers or load balancers on the left. We have the AG or access gateway. These appliances, as I mentioned earlier, that the OS is proprietary. It's fully hardened. We were unaffected by Heartbleed and Poodle because we're not exposing open standards to the internet. We also customized, we have a thing called Speed Core. Essentially, we took that OS, stripped it down to the kernel, rebuilt it from the ground up, and purpose-built it for SSL. I mentioned the layer 3 stateful packet filtering, endpoint security. That's another layer of security. Another layer of, with the load balancers, layer 4 TCP inspection, advanced AAA, meaning authentication, 2-factor. And then by the time you get down to the application layer, we've gone through many layers of defense. I mentioned the hardened OS. It's all about being proprietary. It's also flexible because it is software-based. It's very easy if there is a vulnerability exposed to have the developers somewhat fix that, patch it, and get it out there. Fortunately, it doesn't happen too often, but once again, in security, never say never. All of our solutions provide high availability, HA. So you can have active, passive, active, however you need to do that. And just once again about hardware, because we were proprietary with Heartbleed, we were in a better position at that time. And these are just some of the exploits which I've kind of beat to death today. This is the product suite. On the left-hand side, we have our APB series. That's our load balancers. If you're familiar with F5 or A10 or NetScaler, we compete nicely with them. We have a full range of products, though. Where we do very well, too, is on the low end, because we have products that compete against Barracuda and Kemp, but you get the features and functionality of those high-end solutions. In the center is our WAN optimization. If you're familiar with Silver Peak or Riverbed, we're right in line with them. We're all formidable competitors. There's some things we do well, some things they do well. The AG series is our access gateway. That's the SSL VPN. That will either allow a full network connection or this desktop direct that I mentioned. Access to web apps, let's say, or access to a desktop, which would be desktop direct. That's been a big seller for us, because that's all about taking an untrusted device like an iPad or a home PC, terminating that session, allowing them to connect in and get their work done very efficiently. All of our solutions come in virtual or hardware. The benefit of hardware is we do the SSL on a hardware appliance, which you'll get better performance or better acceleration. The thing about virtual is it's very flexible. It's very easy to provision and deprovision. So what we've done is IBM SoftLayer is a customer of ours. They provide load balancing as a service. We created an appliance, 1 or 2U, that will actually allow you to run 8, 16, or 32 load balancers or access gateways in a single platform. What this did for SoftLayer was it gave them the flexibility of a virtual environment with the guaranteed performance of hardware. And that's it. Any questions? Quick questions? Good morning, everyone. I'm Rich Harrison. I'm the regional sales manager.